In this second video, we're going to take a look at section 2 of the exam, where you had a choice between questions 2 or question 3. In question number 2, we took a look at BJSG ribs in Mankato, Minnesota, had a labor demand relationship of labor demand equaling 75 minus 6W. You were given information that it's a profit maximizing firm in a competitive market, both for its output good and its inputs. So its labor market is competitive, its goods market is competitive. That means that firms don't set prices and consumers don't set prices. The market has set the price, kind of organically. And and we see there that we have the price of ribs set in that market, ribs being the good that is manufactured here, of $3 per unit. And you're given a little table where we have wage and the quantity of output. Well, if we know the wage and we know the labor demand relationship, we can plug the wage into the labor demand equation and get the number of workers. So in this case, if 7 is W, we then have 75 minus 6 times 7, or 75 minus 42, which is 33. And so on, and we get 30 and 27 and 24 and 21. Then we look for the marginal product of labor in the next column. The marginal product of labor, of course, is the change in quantity of output divided by the change in labor units. And in this case, the change in quantity of outputs is 7, and the change in labor units is 3, so 7 divided by 3 is 2.33. An error I saw some of you make is that you put this number, 2.33, in this cell. Well, you didn't change before you got to that cell, or to the extent that you did, you don't know what you're changing from that was up here at a wage of 6.5. You might have known how many workers, but you didn't know how many, what the quantity of output was at a wage of 6.5 and the number of workers that would be commensurate with that. So this really doesn't have a value. Similarly, the marginal revenue product of labor in this first row doesn't have a value unless you know what you're changing from. So that caused a couple of you some minor heartburn here. Well, so we have 2.33, 2.67, 3, and 3.33. Then in the price, and this is the price of the output good, as I've explained, as you've seen this structure before, it was 3, and it's 3 all the way down because it's fixed in this market. So finally, we get the marginal revenue product of labor, which is the marginal product of labor times the price of the output good. So 6.99, 8.01, 9, and 9.99. It's probably worth indicating here what we're about to look for is, on the next question, is the number of workers that you would hire based upon this profit maximizing firm in this competitive market. Well, we know in the profit maximizing firm, the competitive market is looking for a relationship to set its number of workers at where marginal revenue product of labor is equal to the wage. Well, in this case, we don't have it exactly equal. We have marginal revenue product of labor at 8.01, the wage at 7. That's as equal as we get, and we do have the relationship where we're a little bit greater in revenue productivity than we are in wage, just a little bit. If we step back to the next number of workers that were available to us, now we have MRPFL being less than the wage. We don't want that. We're getting less than we're spending. Or if we go to the next unit of labor above this condition, then we have wage at 8.5 and we have marginal revenue product of 9. And yes, we are in a position where we have a marginal profit, if you will, on the workers. We have a fewer number of workers, so fewer number of output goods, and we're making less money. So neither of those are optimal. This one's just barely an inequality, and it's an inequality such that the MRPFL is slightly greater than W, so that's the one that we default to at 27 workers, paying them $8 an hour. So in part C, we said if this firm had a marginal product of capital at the number of workers indicated. So remember, the number of workers indicated should have been 27, and where we had a price of labor at 8, and we had the marginal product labor at 2.67. So if in that condition the marginal product of capital was 12 and the price of capital was 30, what would you recommend in order for the firm to reach some level of profit maximization? Well, this was the balance condition that we're setting up, where you have marginal product of capital, price of capital, and marginal product of labor, and price of labor or wage. And we set up this equation, and then we go ahead and substitute in for these variables the values 12 and 30 and 2.67 and 8. We don't know if they're equal, so we test to see if they are, and in fact, where they're not equal, we're at 0.4 being not equal to 3.34, or 0.4 is of course greater. So we want this number to become greater in order for these two values to become equal. Well, the reason I say it like that is because this is the management decision that we have to think about. So managers in the short term can't change the price of capital or the price of labor. In fact, they can't change them at all. Firms are price takers in these competitive markets. So we can't change this. We can't change this. In the short term, we can't change the marginal product of capital because it takes time to put capital into place in our production environment. The only thing really we can change is the marginal product of labor. And how do we change the marginal product of labor? By changing labor units. So if we want this term to be greater, means the numerator has to become greater, and we increase the marginal product of labor by decreasing the number of workers. Then finally, I asked you to give me something of the implication of the adjustment that you'd recommended. So think about this. If we decrease the number of workers, it would result in possibly having some W that's equal to marginal expense of labor, but maybe it would be less than marginal revenue product of labor. Well, that might be an explanation in a market with some friction, but you could have thought about that. We're saying that condition may be sustainable, but only if the firm held some power over the workers, which would be a market with some friction. But what we know is we're going to have some kind of an imbalance here that is going to be set up, and so we have to think about what else might need to change. I accepted most any discussion you gave me here that seemed at all plausible. That let me see whether or not you were thinking through this at all. Okay, so now question number 3. So we have John, a college graduate, mid-level executive in a technology storage firm, lots of experience, has a wage of $30 an hour. He has investment assets giving him $40 a day in personal income. That's $200 a week in this case, so apparently we're thinking about a 5-day week. His daily budget requirement is $300 a day or $1,500 a week. He's a supervisory employee, so he doesn't get any overtime premium. His employer lets him work as many hours as he wants a day, but he only works 5 days a week. I gave that condition to make this a little bit simpler for you. And then I asked you to give me the labor-leisure trade-off model, which model we know in the x-axis has 0 to 16 units of leisure and 16 to 0 units of labor on the x-axis, and then on the y-axis we have some money represented. This can be money from wage, money from endowment, money from unemployment, money from something. And in this case, John's got an endowment, an investment asset. It gives him $40 a day, and he still has 16 hours of leisure. He doesn't have to get out of bed to get that $40 a day. So we see a line coming up vertically from 16 hours of leisure up to the point commensurate with $40 of income, and then we go ahead and do our budget that goes from 0 hours of labor to 16 hours of labor, so from $40 all the way up to $520, the difference there being $480, of course. And if we take a look at the $30 wage times 16 hours of labor that we might be able to have, that would be then the $480. So we should have seen 40 on this axis. We should have seen 300, which is his daily budget requirement. We should have seen 520. We should have seen 0 and 16 and 16 and 0. Everything needs to be labeled properly, and then you're responsible in this relationship to identify, how many hours is he going to work. Well, if he needs $300, then we can take 300 minus the 40 that he's going to get regardless, so that leaves us with $260, and 260 divided by 30 is 8.67 or 8.667 hours of labor. Well, if we have 8.67 hours of labor, we must have 7.33 hours of leisure, because those combined are 16, just as these combined are 16 and these combined are 16. So I've asked you to give some representation of his tastes and preferences as well. That's his indifference curve, the curve on which his utility is constant, and that curve is going to be tangent to the budget curve at the point where his income need is met. So we've got the indifference curve coming along here for John. Might be interesting to note for you that if he was going to have greater level of utility or happiness or satisfaction, the curve would be out here, but he doesn't have enough money for that. Or if we have less, maybe it would be in here. He has too much money to suffer that condition. Then I ask, assuming John is a participant in a competitive labor market and the output price of his firm's product is $1,000, then what can you tell me about his weekly marginal productivity? Well, we're looking at a scenario where we're going to think about the wage and the marginal revenue productivity to get to marginal productivity. We know that in a competitive market, wage is equal to MRP of L. John is in a competitive market. You were told that. John's weekly wages, so the amount of money that he's actually earning from working, not plus the endowment, but he's earning from working, is $1,300. He's getting $1,500 in total. $200 of that was from his endowment, so he earned $1,300 from working. So we then know there's $1,300, which is going to be his W, and W, or MRP of L, since they're equal to each other, is equal to the marginal product of labor times the price of the output good, which was $1,000. And we can rearrange that algebraically such that we see the marginal product of labor is 1.3. This is virtually identical to one of the examples I gave in one of the videos when we dealt with this section of the course. And then part D, we said, given what you know about John, how would you describe his relative skill level and overall level of utility? Again, here, I would have accepted almost any answer that seemed credible and well thought out. I've said that at the wage plus the endowment of $300 a day, we can suppose an annual income of about $78,000. That's relatively high. For our labor market. It's not huge money, but it's relatively high. It's certainly well over the average worker. So maybe he gets a lot of satisfaction from that. But his leisure is a little bit diminished. He's only got 7.33 hours of leisure. It's a little bit diminished. So maybe that's a little bit low. So I'm going to say his utility is probably fairly average. Now, if this had been me, 7.33 hours of leisure a day is much more than I typically have. I enjoy working. I get a lot of satisfaction from working, so my work hours in a day are far more than 8. And so if I had this income, if I were John with that income and with this much leisure, I might think I had a very good life. So it just depends on how you might approach this. But again, I accepted most any reasonable answer on this. And that's how we finish off section number 2.